Hello. I think you should be able to see my desktop and you should hear me. Does everything seem okay?
Yes.
Okay, great. Let me pull up, let's see. I get the chat window up. Zoom has changed my interface. So Zoom's working differently than it did just a week ago. And I'm getting confused by it worked one way for a year and all of a sudden windows pop up different ways. Okay. Okay. So what we're going to do today, well, first of all, there's a new programming assignment. So mention a little bit about that. And then we're going to start this language 7, which is really a big jump. It adds a lot to what we've been doing. So your current the new homework assignment is based on language 6. Okay. So well, okay, everything you need is in homework 3 folder. So if you open, so the homework 3 folder's got a lot of files in it. Okay. So this outlines a new language. Like if you compare it to folder 6, you're creating a language 6A in homework assignment 3, and here's language 6. Okay. What's what's extra over here are some output files. For the most part, everything here is the same as it is over here. And your job, like in the last assignment, is to update this file here. Right now, this file here is this file here. They're the same file. Like if I open them in TextPad, I can diff them. Tools, compare files. See, they only differ by a little bit at the beginning. This one has the grammar of the language you have to write at the top of it. This one has the language of grammar 6. But then the code, once you get past this introductory stuff here, once you get past, all the code is exactly the same. The last diff is the name of the file here. Okay, so this one's called evaluate 6A, and this one's evaluate. Okay, so you have to modify the code. Okay, so this is the language of 6. It's the language of, it added if and while statements to the language of Boolean variable. Like this is the language of a Boolean calculator. Okay, you can create variables and set them and do Boolean and arithmetic operations on them. And then we added if and while. That was language 6. Language 6A, you're going to create a for loop and a repeat loop to complement the while loop. And then you're going to put your operators from last homework assignment in here also. So language 6A is your operators from the last homework assignment with a new for loop and a new repeat loop. And the for loop is the loop that really uses these operators. Like when you write for loops, you like to write I++. So these operators from the last language will get their real use in the for loop operator the for loop expression you put into this language. Okay, so here's the new for loop. It's got 4 parts to it. Remember, if you think of a for loop in Java, you write for the initialization part, the bool part, and then the update part. And then you have the body. So there's 4 parts. There's a for loop has initialization, Boolean, update, and body. And that's what this is. Initialization, Boolean, update, body. Okay, so it's the same 4 pieces. Okay, all right. Okay, so, and then a repeat loop in Java, this would be written do body while Boolean. Okay. So there's two parts, body, which is this expression, and Boolean, which is this expression. And I just wrote it as repeat. Yeah. In Java, it's a do while loop. I called it repeat loop. Okay. So repeat this expression until, yeah, sometimes people call it, in some languages, it's written as repeat body until bool. Yeah, until the Boolean is false. You know, repeat this until usually it's until this guy is false. Okay. Okay. So you do this, then you compute this. If it's true, you go back and do this. So while this is true, you keep repeating. Okay. Yeah. And you repeat until this thing becomes false. Yeah. So some people like to write it. Some languages have it this way. Some languages do it this way. Okay. All right. So do this expression, then check if you should do it again. Then do this expression and check if you should do it again. Okay. The return value of this expression is the last time you evaluate the body. The body then becomes the return value. Remember the while loop, you check this thing. If it's true, you do this. And then you check again. If it's true, you do this. And you do this until this is false. Trouble is you may never do this. You can't make it the return value. For a while loop, you can't say that this is the return value, because if this thing initially is false, you never do this. So the return value for a while loop is always false. The same thing is true for a for loop, because the for loop is really just a mask, it's just a fancy while loop. So you may never do the body. You may never do this body. If this thing is initially false, it's just like a while loop. You do this guy once, you do this guy once, and if it's false, you never get to this and you never get to this. Okay, so the for loop always returns false, while loop always returns false, but what's nice about the repeat loop is it returns that expression, because it always does it at least once. You come in, you do the body, save the result. If this is false, you return that saved result. If this is true, you go back and do the body again, save the result. If this is false, you return the result of the body. Okay, so that's what. So a repeat loop really does return a real value, as opposed to for loop and while loop, which they always return false. So that makes the repeat loop kind of nice, because it's actually really an expression. It returns a useful result, not the same thing all the time. So another way to put it is the only use of a for loop is to do side effects. A for loop can't compute a value. It can only do side effects. Put variables in the environment, update variables in the environment, print things out. Same with while loop. It's only useful for side effects, putting things in the environment or printing things out. The repeat loop can be an expression. Repeat loop can do a useful calculation. So that's it's kind of interesting that the repeat loop, even though it's usually said that while loops, repeat loops, and for loops are all synonyms for each other. One thing, what you can do with any of them, you can do with the other. That's true when they're statements, like in Java and C++. But when you make them expressions, the repeat loop is a little bit different. When you make them expressions, the repeat loop can return a value. It can return a useful value, unlike while and for. Okay, notice that's like if. Remember, if in Java is a statement, not an expression. But in our language and in most modern languages, if is an expression, it returns a value. If this guy's true, it returns that value. If this guy's false, it returns that value. But it returns a value. Whereas in Java, an if statement has to have side effects. It doesn't return anything. You do an if statement for its side effects. It prints something or it updates some variable. It either prints something or puts something in a file. It has to do some side effect, printing something, storing something in a file, updating a variable, but it can't return a value. But in this language, and most modern languages, if expressions return a value. Okay. All right. And if you look in this examples file, you can see that there's things like, let's see. Oh, I opened that's a test file. After you update the language to language 6a, you should make sure that language 6 isn't broken. So these are language 6 examples to just make sure a regression was usually referred to as a regression test. You don't want to break any of the stuff that was working. So that's a test file from language 6. And here's the language 6a examples, the test file for language 6a. See, in the for loop, see, set the variable, test, increment. So see, that's where I use the pre and post increment operators and the decrement operator in the for loop, because that's where that's where you would usually see them. So for variable declaration, test, increment, then here's the body of the for loop. Okay, that's all one for loop. See, I wrote it in 2 lines, but that's all. I wrote it in kind of a Java like C++ like 2 lines, but that's all one expression. Same here. That's all one expression. But notice that that for loop has a begin in it. The body of this for loop is a begin, so it can have multiple statements in it. The for loop in our language is just like the for loop in Java in the sense that the for loop has only the body of the for loop is one expression. If you want multiple expressions in the body of a for loop, you have to use braces in Java, or you have to use a begin in our language. So if you want multiple statements there, you have to use a begin. Just like in Java, if you want more than one statement in the body of the for loop, you use, like here, I really shouldn't put braces there. There's one statement there. The body is one statement. Okay. If you want multiple statements, then you wrap them in braces, which is a brace statement. Okay, a block statement. So for loop has one statement in it. Now here in Java at least, I think you have to have the braces there. I can't remember if the syntax, like if like a procedure call requires braces as part of the syntax. I don't know if this is, I actually don't even know if this is just statement, and you can put one statement in there, or if you're required to put braces. I actually don't even know offhand the exact. I almost never use the do while loop's not that is often used in Java as, say, just a for loop is. But I don't even remember if that needs if that requires braces around it, or if you can write it like that, like you can write a for loop with just one statement here. If you can just put one statement here between the do and the while. Okay. Okay. So the body, I actually don't even remember what the exact syntax, but here, if you want multiple statements in that body, you use a begin statement. Okay. The begin statement is the way we lump multiple expressions together in this language. Okay. All right. One real important thing in this assignment, go back to the web page that describes it. You need to know the difference between those two. Okay, this is a real important. I mean, I'm not going to. If you haven't ever thought about this, you should really think about it. What does it mean to declare that variable first and then enter the for loop versus to write the for loop with that variable in the for loop? This actually creates a local variable for the for loop. Here, the scope of this variable is outside of the for loop. Here, the scope of this variable is inside the for loop. You have to implement those two. You have to, the for loop in this assignment has to work like Java does. This doesn't mean the same thing as this. And in the test cases, see, here's a for loop with a local variable. Here's a for loop where the variable is declared before the for loop. So that is just like this. Declare the variable, then initialize it, but it's declared here and then initialized here. See, it's declared here, and then it's set to 1 here. So that variable is declared before, yeah. And then here it's, see, this declaration here is then overridden by that declaration there. It's like in the Java case, if you declare an I outside here, then you have 2 I's, and this one would hide, except in Java, you're not allowed to do that. In Java, you can't have an I out here and an I in here. In C and C++, you can. You can have an I out here and an I in here, and then this I hides the outer one. Java doesn't let you do that. In our language here, this I is not that I. This I is local to the for loop. This print is printing this I. These prints are printing this I. Okay, so your for loop has to do this scoping properly. Okay, and here it's even more elaborate. There's 3 I's here. Here's a global I. Here's an I that's local to the for loop. Then here's a begin statement with its own local I. Okay, so this prints this I. Okay, this prints this I, and the loop I is never printed. It's incremented, but it's never printed. But there's 3 I's. Java doesn't let you do this. You can turn this into C code, and you can turn this into C++ code. You can't turn this one into Java code. Java won't let you have one local variable hide another local variable, and then another local variable hiding that local variable. I have 3 environments here. I have an environment chain with 1, 2, 3 environments. That's what you're going to have to implement. This is an environment chain of 3 environments: the global environment, the for loop's local environment, and then the begin block's local environment. And they're chained to each other. I should have created an example where you had to look up variables in each one of these. Like here, these are hiding each other. This one is hiding this one, which is hiding this one. I should have put an example like print. I should have had right here. Var x2. Okay, so that creates a global variable x. Okay, then here this could have been like print the sum of I and x. That I would be this I, but that x would be this global one. You can put 2 variables, like if you go back to Java. No, in Java, you can do things like in C and C++, you can initialize more than one variable. Int I equal 0, comma, j equal 0. Okay, you can use the comma operator, and you can actually declare 2 variables. Okay, so that's 2 local variables in this for loop. You can do that in this language too. I didn't do a test for it, but you could put a begin right here. You could say for begin var var I1, var j2. I think that'll work. I think that'll create 2 variables. Okay, but it actually is complicated because that actually creates another environment chained onto the for loops environment. So that actually creates 1, 2, 3, 4 environments: the global environment, the for loop environment, then this environment that's local, that's chained off of this for loops environment, and then this environment will be chained off of that environment. Okay, so you can mimic most of what we do in Java in this language, but it becomes a little bit cumbersome to write it. Okay, but you have to implement That's one of the key steps in this homework assignment, for you to understand what it means to create a local environment. Essentially, the for loop acts a lot like the begin statement. So what you need to do is, when you're implementing for, go look at what begin does, because begin is the main way we create a local environment. So for has to mimic a little bit of what begin does. Okay, so remember, when you want to write for, go look at how begin works, because begin is the one way we have in this language to create local environments, and for imitates begin. Okay, all right. Now, when I wrote that example I wrote here, this put a begin inside of that expression. So that's actually another. So that creates two environments here: an environment for the for loop and an environment for the begin. Okay. All right. Actually, I have to think about whether this one works or not. I should try. I'll have to test that one. I'm that may not work in this language. That may not actually work in this language. I'll have to remember to play around with that one to see if it's not one of the tests you have to work with. So but I'm not positive that one should even work. I have to think about that, whether that should work or not. Okay. All right. Okay. Now, all this is described in the file that describes the language. So here's the file that describes, oops. Oh, I forgot to update that file. Ooh, this is an old version of the file. I forgot to update that. That's real important. Ooh, I got to remember to do that. There's supposed to be here a long description of the meaning of this language, and I wrote it in a separate folder, and then I forgot to update this folder, the zip. I forgot to update the zip file for the homework assignment. Okay, so I can show you real quick. Okay, here's what it should look like. So here's, after class, I'll fix this. Here's an explanation of what for loop should do. Here's an explanation of what repeat should do. Okay, so between the description on the website, between this description here and this description here, you should have enough information on how to implement the for loop. Okay, and then you'll go into the interpreter. That's this file here, evaluate 6a, and you have to add, just like you did for previous time. You have to add, if the node is a repeat, or if the node is a for loop, you have to write an evaluate for and an evaluate repeat. You're going to write an evaluate for and an evaluate repeat method. See, so and evaluate repeat will look a lot like evaluate while, just a little bit of switching things around. Evaluate for will be kind of a mixture of a while loop with begin. Okay, so I think you can, you're more or less, if you understand how the things work, all the code you need is in here. You just kind of piece it together. Because most language constructions are similar to other language constructions. So for, while, and repeat loops are pretty similar. So right now this language already has while in it, and you can basically use the while to implement the for and the repeat. But then the for loop needs to duplicate the begin. So it needs to know how to create a local environment. Okay. All right. So you'll be adding to, you'll only need to write, you'll only modify, out of all the files in this folder, you're only going to modify that one file. You're going to modify the interpreter, which is the evaluate function, and then you'll be able to run this test program. You run this test program. When you run the test program, you should get the output that looks like, this is what the output looks like without debugging turned on. And this is what the output looks like with debugging turned on. This one's a little easier to read. So you can see if you can kind of see what the programs are doing. Okay, this is a little bit easier to read, but this one helps you debug. If this one tells you how the language is creating environments, if you trace through here, you can see what the interpreter is really doing. You can see how the interpreter is building environments, and that could be useful when you get down here. See, this environment was put there by the for loop. See, there's a global environment. When the program creates the global environment, then this for loop created this local environment. That's there for the for loop. Okay, right? So then the for loop's going to be, there's the I in the for loop. See, and there's the I in the global environment. So this I is in the global environment, this I is local to the for loop. And see, this debugging lets you kind of see what's going on. There's two I's, one in the global environment and one in the chained local environment. Those created by for. And then this is updating that I. Okay, and you can kind of see how I is updating 1, 2, 3, 4. Okay. Like in this example here, that's a global I. That's the I in the for loop. There's another I that's in a begin block. And if you go down here, there's the global environment. Then the for loop kicks in and creates its local environment. And then the begin kicks in, and there's 3 environments. Okay, this one created by begin, this one created by the for loop, and then the global one. Okay, so you see that there's 3 environments. Okay, and then then it loops along, then it's going to loop. Okay, when the looping is done, the local environments will go away one at a time. See, like here, there's 3 environments, and now we're back just to 2 environments. And then there's just the global environment. Here we're down to 2 environments. Okay, so the debugging, if your code isn't working right, you can trace through here to see what should be happening. How should the environments being created? It's a lot of output, but it's typical debugging output. It doesn't matter if you're debugging this kind of thing or you're debugging web servers or database servers. When you debug things, you get lots of code, traces, and log files, and you just start reading carefully in the trace file or the log file to try to figure out what's going on. So this is a trace. This thing's mostly it's tracing the creation of the environments. Okay, so it's letting you see how the environments are being created. And if you just want to know what the program puts out, that's what this one does. See, there's the printouts. That's these. And then here's the return value of the program. Okay, so there's the printouts from the prints, and this is the return value of the program. Okay, so this one's the return value of the program, and then these are the results of the print statements. Okay. So this is easier to read. Here, this is pretty printing of the program using your pretty printer from the last homework assignment. You have to put your pretty printer from the last homework assignment in this homework 3 folder. Right now, the pretty printer that's in there is a stub function. It doesn't do anything. So you replace it with your pretty printer from the last programming assignment. Okay, so you should match these pretty printing outputs also. Okay, I provide you with this pretty printer, the one that gives us the infix, the like C-like notation. So that's this file here. Okay, I give you that. That takes this tree notation and prints it so this is pretty printed tree notation, and this is the tree notation converted to infix notation. So it's in infix, I equals -1. Okay, yeah, I equals 0. So it's in infix notation, I less than 4. Instead of writing less than I4, it's pretty printed in traditional infix notation. Okay, so you have to write that pretty printer, or you should have it written. It should be the same pretty printer as from the last homework assignment. So there's, you put your pretty printer from the last homework assignment in this file, in the folder, and I gave you this pretty printer. Okay. And here that's what the program looks like in our language. That's what it looks like if you translated it into C or a C-like language. And then here it's its output. And this one, it's just got more output because it's got the debugging information. I mean, there's the pretty printed version, there's the infix printed version, and then there's the debugging information mixed with now the debugging information is mixed up with the printouts. That's a printout. Oops, that one's a printout. That's the result of a print. Okay, and then this is something that modified the environment. Then this was a printout, and this was something that modified the environment. The thing that's modifying the environment is this guy here, the update. So in between printing, you're doing this updating. So the output looks like print, update the environment, print, update the environment. And in the environment, you see the eyes going from 2 to 3. So it's print, update the environment. Okay. So it takes a little bit of practice. It takes a little bit they're not, it's not easy to read, but no log file, trace outputs and log file outputs are never easy to read. There's usually so much information in these things, stack traces and log outputs. There's usually so much information in them that they're hard to read. So it just takes a little bit of effort to get used to how they're written. Okay. Okay. Let me think. Out of all these files, remember, you're only going to modify one single file. All your code's going to go into that file. You will put your pretty printer from the last assignment, you replace this one with your pretty printer, and everything else, you just leave it. Yeah. And then when you've updated this guy, you should be able to run this guy and this one. This one should produce the same output as before. You shouldn't break anything in language 6, and you should be adding the features of language 6a. So this is a really important one. This is where you're testing the features you added to the language 6a. Okay. Okay. You get the 2 different debug outputs. Where is it? Right here. See, there's where you can, there's right at the beginning. The variable is actually in this file here, but it's a public static variable. The debug variable is actually in the interpreter, but it's a public static variable. So in the test file, the first thing the test file can do is choose whether it wants lots of debugging or little debugging, no debugging. So you set the debugging anytime you want. The reason for doing it that way is in a real environment, you would maybe want to debug one of these, but not all of them. So you could turn off debugging. Then when you get to a problem statement, you could turn on debugging, then turn it off again. And that's actually a pretty common thing in the real world, is you turn off and on the debugging, because otherwise, like if you just want to debug this one guy, you don't want to get thousands of lines of output, you could turn on debugging just before this and then turn off debugging right after this. I mean, you wouldn't do it in there, you do it in this for loop. But in this for loop, just before you process that one, for example, you could turn on debugging, and then right after you process that one, you could turn off debugging. So then you just get debugging output for that one expression. So that's the reason for allowing this program to set the debugging in the interpreter. So the debugging flag is in the interpreter, but you want it to be public so that a program that's testing things can turn off and on the debugging level so that it can control how much output gets generated. Okay. So here I'm just setting debugging to 1 and then running all the test cases. or setting debugging to 0 and then running all the test cases. But what's more interesting in a real environment is to turn off and on that flag when you need it. Turn it on when you've got something you don't understand what it's doing. You can turn on the debug flag, process one expression, and then turn off debugging. Okay. I think that's it for the homework assignment. Anybody got any questions about this? I think I've described pretty much everything you need to know, except, yeah. Oh, and I gotta make sure I put that, I gotta update that, the file with the, I gotta make sure I update this file here. Remember, this build all classes and build jar file will build the jar file so you could run an interpreter, right? Yeah, like right now, if you build all classes, and you build the jar file, you're building language 6. Okay, now we've got an interpreter. It says language 6A here, but right now it's language 6. Okay, so this is just the language 6 interpreter. Okay, so there's the language 6 interpreter. Yeah, so when you've got this file updated, and if you rebuild the interpreter with build all classes, build jar file, then you'll have a true language 6A interpreter. And then you could test things in the interpreter yourself. You could write like right now, I can write a while loop in here, but I can't write a repeat loop. When you're done, you'll be able to write a repeat loop. You'll be able to write a repeat loop in the interpreter. Okay. Okay. So, but yeah, right now the script files build language that, everything in here right now is language 6. This is just language 6, and what turns it into language 7 is when you rewrite, you update the interpreter. Yeah, you update that one file, and you'll convert it from language 6 to language 6A. Okay. Anybody got a question about the homework? Okay. Okay. Let's
Yeah,
turn to the next language.
yeah, Professor. We need to use our Pretty Printer 2 version, right?
Yeah. Your pretty printer from assignment 2 is the one that should work in this one. It should give you the same output. It should give you the output that's in this. It should give you that output, that pretty printed output. Okay. So that's the pretty printer from assignment 2.
Okay. Okay. Thank you, Professor.
Sure. Any other questions? Okay. Let me. I want to remember this one. I'm going to check if that one. I want to make sure to test this one. Okay. I'm more. It's more curious. I'm not going to change the test cases in the assignment, but I'm just kind of curious if that one is actually a valid test case. I don't even remember if the language will work properly with if it should even work properly with a begin statement there or not. Okay. All right. So just now, let's see. Okay. Now, I want to start talking about language 7. Okay. language 7 is a big jump. We're at it's what the course is really about, because adding functions are the heart of programming. So adding functions to our language is a big deal. If you notice that so far, everything we did was really not that hard. So far, the biggest thing we did was add environments, okay? If we think about the progression of the languages from language 1, 2, 3, 4, 5, 6, 7, so far the biggest jump was adding environments. And that's a real important thing. And environments are going to play a big role in functions, okay? So actually, I purposely broke this up so that environments are introduced before functions, because in most courses like this, environments are introduced when you introduce functions, okay? Because the real use of an environment is to implement function calls. But that even makes functions even harder. So I thought it'd be better to introduce environments as a separate step, because it just lets you create local variables. So you can think of it as like a calculator with local variables. Okay, so the environment's a big step, and now we want to add functions, and like I say, that's even a bigger step, and it makes a lot. The functions actually are you can't have the functions without environments. And like I say, most courses that are taught like this, they actually introduce environments and functions at the same time. Okay, now what we need to do, let's see. So here's the language 7 grammar and semantics. Okay, so here is the grammar of the language, and then here's an explanation of what's new in the language. Yeah, there's a lot to talk about. Functions, there's a lot to say about functions. Yeah, as opposed to like if statements. Remember, if statements was trivial. An if statement, well, it's just 3 pieces. You evaluate this. If it's true, you evaluate that and return it. If this thing's evaluate this and it's false, you evaluate that one. Yeah. So you only do one of these two. That's real easy to explain. While loop's not much harder to explain. You evaluate this and it's a Boolean. If it's true, go and do this one. If this one's false, just quit. Okay. So and in the homework assignment, you're doing repeat and while loops, or repeat loops and for loops. They're not that much harder. Print is super easy. Just evaluate that expression, print its output, and then return whatever that value is. That's what you return, and you also print it at the same time. This is just arithmetic, which is just a post-order traversal of a tree. The way you do arithmetic is just do a post-order traversal of the expression tree. So that's a big, in a sense, you can say that's our first big step, is the idea that evaluating an arithmetic expression is a post-order traversal of an expression tree. Okay, that's one big step. Okay, the if and while are pretty straightforward. Okay, then these 3 were the environment ones. Okay, we have a global environment automatically. So with the global environment, we can set variables and look them up, but we can also create local environments if we want with the begin statement. And then we could set variables in the local environment or set variables in the global environment. We talked about different scoping rules. Once you have local environments, you have this notion of scoping rules. What is the right way to handle inner and outer scopes? Okay, remember, real quick, I'll use like a Java notation. Now create another scope, and then you do, okay, what should that mean? How should that work? Well, Java doesn't let you do this. In C, this one hides that one. So then if I print I, in JavaScript or C or C++, this would print 5. Java, this won't compile. Java doesn't let you have a local variable hiding a local variable. So notice that you have to decide the semantics of what you mean by local scopes. See, in our language, this would be a begin. And in our language, this one hides that one. And then if you close the scope and now you print I, what should you print? I mean, you have to decide what the language means. You could print 5. This I could be that I still, in which case you really wouldn't even have local scopes. So there are languages like that. This I and that I are the same I. In fact, that was our language 3 was like that. In our language 3, we only had one scope, global scope, so that these were all the same I. Okay. In what we call lexical scope, usually this I hides that one. So this one is that one, but now this one's back to that one. Again, Java won't let you do this. Okay. Java, you either can have that I or you can have that I, but not both of them. Okay. Java won't let you have one local variable hiding another local variable. Now that's not true for static variables and instance variables. If this is a static class variable, then a local variable can hide it. But a local variable can't hide another local variable in Java. Again, you have to nail down what your scoping rules are. Okay. Yeah, just putting a block structure doesn't tell you what things mean. Java, JavaScript, Python, C, and C++ all have slightly different meanings for these blocks. Okay, for example, here's a real good one. What does that do? Okay, if it's C, you print. In C, this prints 3. In Java, this won't compile. In JavaScript, this prints undefined. Does anybody remember why? Why does that print undefined in JavaScript?
You didn't hoist it?
No, it does
Yeah.
hoist it.
Oh, it does.
So what does that mean?
Oh,
This
it's above
I
the
is,
int I.
yeah, this I is hoisted up to here, but why is it print undefined? This I is hoisted up to here, so that means it's declared up there, but it doesn't get a value to that line there. So at this line, it doesn't have a value yet. So when you print that I, it prints undefined because of JavaScript's hoisting rules. Okay. Notice that that's completely different than what C would do. C would print that. C would print that. Okay. Java won't compile it. C prints 3. See, Java won't compile. C prints 3. JavaScript prints undefined. Literally prints the word undefined, where C prints the value 3. Okay, same piece of code. You can write this code in Java. You can write this code in JavaScript. You can write this code in C, and you'll get 3 different scoping rules. Java doesn't allow local variables to hide local variables, so Java won't compile it. C allows local variables to hide local variables. So, but this one is the global variable here, and then this one will print the 5. Okay, and back like in here, Java won't compile. C prints 5. JavaScript prints 5 now. Okay, because now this is the local I. Okay, so now JavaScript would print 5. It's been defined at this point. It's been declared, and it got hoisted up to here, but then it got its value here, so now it's 5. Okay, and yeah, so you get 3 different languages from the same little piece of code. 3 different languages give you 3 different semantics. Okay, they give you 3 different semantics. One has the semantics of not compiling. It's when it says it won't compile, it parses. This is valid Java in terms of parsing. It's syntactically correct. It's semantically not correct. So when it won't compile, it's not compiling not because of a syntax error. It's what we call a semantic error. Java says you cannot declare a local variable and then redeclare another local variable that hides it. So it's this guy that's causing this guy not to compile. Okay. If you comment out that, then this thing compiles and prints 3 in Java. Okay. Then this thing is just that one there. So it's this one that causes Java not to compile because of that. So this is that one, like just like in C, but then you have to get rid of this guy here. You can't, in Java. As it is now, Java won't compile. This is that variable in C. This is that variable in JavaScript because of the so-called hoisting rules. Okay, notice how in C, that I is that I. In JavaScript, that I is that I. Very weird. JavaScript's weird. Okay. The syntax does not tell you what it means. The syntax just kind of, the braces are supposed to create scopes, but the exact meaning of a scope depends on the choice of the language. So you have to know the exact semantics of your language to know what these scoping rules do. So that's why we introduced begin before talking about functions, so that we can talk about scope without having to talk about functions at the same time. Okay, so we've talked about the notion of scope rules without having brought up the notion of functions. Though, like I said, if you look in a lot of books on interpreters and compilers, they throw the environment and scope rules right in with the functions, which is a bit misleading because here, I haven't declared any functions there, and I still have to worry about my scoping rules. I have very distinct scoping rules that have nothing to do with function declarations. Okay. And again, in Java and JavaScript, I also have to worry about, right now I'm assuming that's a local variable. If that was a class variable, then Java would be different. If that was a class variable, then this can hide the class variable. Then Java will compile. To make it a class variable, you'd say something like class X int I equals 0. This works now. Roughly in Java, I should indent that. Okay. This compiles in Java. That I is that guy. Then this I is a local variable hiding that class variable. Actually, and I have to put the word static in front of this. And actually, to make this Java, what do I need to do? I would need to put this guy in I would need to make this like a main method. It needs to sit inside of something. Okay. So that's my local scope is a main method. Okay. That I is that one. Okay. Yeah. On your hand, if I do that won't compile. This I is hiding a class variable. This J is trying to hide a local variable. So that won't compile because we're backed up here. Okay. So local variable can hide static variable, but local variable cannot hide local variable. This local variable can't hide that local variable. Okay. Yeah, you have to know. So this guy hides that guy, not because of anything that's syntax. Notice that this is not declared in a different way. It's just that that I there is a local variable. That I there is a class variable. So local variable can hide class variable. And this guy scopes to that I there. So this prints that variable. Okay. This one hides that variable. This one's trying to hide that variable, and Java won't let it. So it won't compile. Okay. Nothing really different in this declarations there. Yeah. It's just that this guy is trying to hide a local variable. That's a semantic error, not a syntax error. It's a semantic error that this is trying to hide what is a local variable. This one's trying to hide what is a class variable. So that's okay. Okay. If this is C, and that's if this is Java. If this is a C++ class, there's no problem here. So Java local variable cannot hide local variable, but C++ can. So if this was a C++ can, there wouldn't be any problem here. This would not be a problem in C++. Now C doesn't have classes, so I can't really duplicate this one in C, but in C++, this would compile, but not in Java. Okay. I don't even know about JavaScript at this point. I forget the rules for JavaScript, unfortunately, are really weird. The hoisting rules combined with the rules for class variables start getting really messy. This is one of the things that JavaScript got messed up. JavaScript ended up with really horrific scoping rules. Okay. Here I'm dealing with nothing but local variables. So that in JavaScript, that local variable is hoisted to here. But this would be in JavaScript, I'd have class variables and local variables mixed up. I don't remember what the JavaScript rules are in that case. I know what the Java rules are, and I know what the C++ rules are. They're pretty straightforward. Java and C++ are pretty straightforward. JavaScript are not straightforward. They're notoriously messed up. And Python also has this problem. Python has problems with its scoping rules. The Python scoping rules for a mixture of class variables and local variables also get messy. Okay, Python didn't do an especially good job of describing its scoping rules. They weren't they goofed. The guy who designed the Python language just goofed up. He didn't pay attention that he was designing scoping rules that were kind of like hard to understand. And same with the JavaScript people. They just didn't realize until later that they had created scoping rules that were hard to understand. The Java scoping rules and the C++ scoping rules are very precise. They're easy to understand and easy to apply. The main thing is in Java, local variables can't hide local variables. And in C++, any local variable can hide any other kind of variable. In C++, any nested scope can hide anything in an outer scope. Okay. And in Java, that's true except for local variable hiding local variable. They thought that was such a bad idea. They thought you shouldn't probably be doing that. They just had the opinion that it's not a good idea on your part to have one local variable hide another local variable. They didn't mind a local variable hiding an instance variable, but they thought that a local variable hiding like the classic example in Java of a local variable hiding it is this. You have class X, and you define a construct. Okay, it's got an int X field and an int Y field. Okay, so it's got two fields, int X and int Y. Then I define the constructor. So public X, int X int y, there's a constructor. And then in the constructor, well, what do I need to do? I need to assign this x to that x. So you can't write x equals x. What do you do? What do you do to solve this problem? That's a local variable. It hides that instance variable. So this guy is hiding that guy because parameters are, what we're going to see. This is why scoping rules are intertwined with functions. So this is a function, and that's a local variable, and it hides that instance variable. But my constructor wants to put that value in that variable. How does it do it?
In that case, we use the keyword this.
Yeah, on the, this is the one that's supposed to be this one.
Yes.
So we say this dot x. That's a scoping. See, that word keyword this is in C++, it would be kind of called a scoping operator. It says the x in the class scope. See, and they like this pattern so much, they thought, okay, that's why a local variable should be able to hide a global variable. Because otherwise you do the following. You do something like you give this thing a funny name, which is what a lot of programmers do it that way. They give these local variables funny names. So then you could say, let the instance variable get the local variable. But the Java people didn't like this. They thought giving a hokey name to these variables is not a good idea. So they let you do this, and then you put the keyword this here, and the keyword this here, okay? And then now you have this local variable's hiding that instance variable. So this x is this x. And notice that this was a lousy word to use for this. This shouldn't be called this. Does anybody know what's a better word for this than this? Because talking about this is horrible. Have any of you learned another, like what Java uses this, C++ uses this, Python uses this, JavaScript uses this. You've ever seen anybody else use something else?
So Python had self, I thought.
Oh yeah, you're right. Python has self. Yeah, that's the other one. Yeah, self. Oh, you're right. I forgot Python. Yeah, it's my. Yeah, you're essentially saying myself. I'm the object. I'm building the object, so it's my x. This one's my x. Self is a little bit better because then I can talk about the self of this object as opposed to talking about the this of this object. Saying the this of this object or this x, like this x is horribly ambiguous because that, what about this y? This y, this y, here this y is a pronoun in the English language. Here this y is a keyword in the Java language. Here I can say this y and self y. See, so this y is this variable. Self y is the y in the object. I really wish Java had used the word self. Yeah, so the Python people, the word self predates Python. It came from an early object-oriented language that was smart enough to use the word self in this instance. This was the C++ people chose this, and they made a big mistake, but then everyone copied them. Java wanted to copy C++, JavaScript wanted to copy C++, so they end up with this. And then people stumble all over themselves trying to talk about this, because this is a very common word in the English language, okay? But the key idea is that local variable can hide instance variable. This should be the instance variable. So I need a scoping mechanism to say, go to the instance variable. Okay. All So you need a lot of rules about scoping. Okay. Now, let's see. Okay. So you need a lot of, you need to have a lot of rules about these things. Okay. Now, in this new language, we want to be able to define functions. Okay. So we need two constructions: function definition and function application. Okay. Here's what I mean. So it's really simple. Think back to algebra class. F of x is x squared plus 3 times x. There's my formula. And then what's f of 2? What's f of 4? Okay. Function definition and function application. Sometimes functional programmers call this application. Traditional people tend to call it function call. Call the function, apply the function, or call the function. Yeah, function application, apply the function, call the function. Okay, so we can say you are calling the function. We could say you are applying. These phrases get used interchangeably. Okay, function application, function call, calling the function, applying the function. Okay, so we need two mechanisms: what the function is and then use it. Okay, and over here usually I would capture the return value. Yeah, so I would the function is going to return me some value and I want to capture it. Okay, so the function gives me back an answer and I'll store that, but that's separate from the function call. So the fact that the function gives me back an answer that I can store, that's the real issue here, is that I have two concepts: declaring the function and calling the function. Now be a little bit careful here. I can do the following. Notice that this is a function call, but this is a function definition. This is where high school students get really mixed up. When you teach this stuff in math classes to high school students, what am I doing here? I'm saying, well, y was defined over here. So whatever the value of y is, that's what you're calling the function with. That's different than this guy, which is saying that the variable in the function is x, and here's what you do with it. Okay? It makes no sense up here to do that. Okay? Yeah, that doesn't make sense. F of 5 is x squared plus 3x. That doesn't make any sense. This is a function declaration. This is saying that the function takes in an input, which I happen to be calling x. Oh, and notice that, like here, these are the kind of ideas we want to get used to. These all mean the exact same thing. But down here, why are these all the same thing? From the point of view of math or Java or C++, these are absolutely redundant with each other. Why? here's what a high school student says. No, professor, those are not the same thing because this is a function of X and this is a function of Y and this is a function of W, so they're not the same. And then you get a job teaching high school and you have to explain to them, no, that's not right. How do you explain to them that that's not right? This is not a function of X. It's a function of what? But you say because F is the same. What do you mean F is the same? It's not the same. I wrote it differently here, and I wrote it differently here, and I wrote it differently here. You have to really, what do you mean? You know, this is not F is a function of X. What's a better way to say it? F is a function of, pardon me?
I was just thinking about it's a function of an input.
Yeah, it's a function of one number, right?
Yeah. Mm-hmm.
And what does it do with that number?
You apply the formula.
Which in this case, you
Oh.
do what to that number? You
Square them.
and then multiply by 3 and add it. But what does this function do?
The same thing.
Yeah, because it takes in one number. It doesn't matter what you called that one number. This is F is a function of one number, and what it does to that number is, now, here's something. What if I wrote this? F is a function of one number.
Mm-hmm.
What does it do with that number?
In that case, that number is nothing is doing to the number.
Yeah, it doesn't use it. Instead it uses this other variable. So this would be, well, it depends. You can make sense of this by doing the following. Now, what does F do with the number? Takes the number and does what with it?
Apply like 7 squared plus 3 times 7.
Right. So it takes.
So it's a constant.
Right. It's a constant. Yes.
Yeah.
It whatever you give it, it returns the constant. Well, see, that would be 49 plus 21. So it returned 70. So it would take whatever number you give in, it would give you back 70, because this would just be a constant now. It's not it's not that variable there anymore. On your hand, if I put it back like this, now it ignores that. Just like, see, it's scoping rules, just like in C++ and Java. Now this W is that W, and it doesn't really matter what I call it. It's saying take the input number. Okay. Now what about over here? What's that W?
That W is the same. It's an input that comes from above.
Right, it comes from right there.
Yes.
Whatever number is in that W, that's the number you give to F. So it isn't like this W is that W. High school kids, really, if you ever had to teach them, you'd be surprised how they don't understand this stuff. They'll think this one is this one, and this one is that one. Something crazy like that. Okay. Okay. So here, F of 2 gives me back a number, and I put that in Y. F of 4 gives me a number, and I put that in Z. Then this Y is whatever that number was there. This W is whatever that number was there. Then this number was whatever was put here. Then I get a value in this X, and then I use that value here, and then I get a value in U. Okay. So these are function calls. These are function definitions. Notice that the function definition has F of W equals, and then you say what it is. Okay. Here, I'm saying f of x gives you back an answer, and I'm putting the answer in U. Okay? So our language needs an ability to define functions and an ability to apply functions. And in the language grammar, this is the thing that defines functions, and this is the thing that applies them. And if you look at language 6 and 7, that's the only difference. 6 has this, I'm sorry, 7 has these two new things. And there's a lot to explain in them. Function definition and function application. And there's a lot explained. You have to, please read this. Please read this. I tried to write a pretty good explanation of what's going on in here. Okay. It's going to take us a while to go through all this. Adding functions to the language is really a deep thing, much deeper than adding variables to the language. We needed to add variables first. No, actually we didn't. I mean, like I said, in some books, they just, variables and functions are thrown into the language at the same time, because as we see here, functions have to have variables. You cannot define functions without having variables, but you can have variables without functions, but you can't have functions without variables. Many books just throw in the variables in with the functions and teach them all at the same time. We've broken it up. We've defined variables first and talked about scoping. And now we're going to use our variables to define functions and applications of functions. So we'll use our variables in function definitions, and we'll, you notice that you don't need a variable in a function application. See, f of 2 doesn't need a variable. F of 2, f of 4. So if I want to save the result, I need to save it in a variable. But I could just do something like print f of 3. So notice I can do something without any variable. I can print f of 3. But the definition of a function absolutely requires variables. Application doesn't need variables, though it could use variables, but function definitions absolutely require the idea of a variable. But the idea of variable can exist on its own, like here, like in block scope. Okay, so we defined variables as a notion of block scope, and now we're going to use variables to be able to create function definitions. In the abstract theory of programming languages, the begin block doesn't exist. Later on, I'll show you that the begin block can be defined in terms of functions. So the books that don't talk about variables until they talk about functions are technically correct. You know, variables, in some sense, variables only exist because of functions, but that's a more theoretical point of view. But in the really hardcore theory of this, variables don't exist until you've created functions. And then there's a way to define begin blocks in terms of functions, and it's real elegant. It forms the basis of compiler design theory. But there is no such thing as begin. A begin is just a special kind of function. Turns out this guy just is a special kind of function. So in a sense, functions are primitive, more primitive than variables. In a broad theoretical sense, function is essentially more primitive than variable, because you can use functions to create the idea of local variables. You can create your local variables using functions. All right. So, but that's a hard way to do it. That's the abstract way to do it. And the abstract way is almost always the hard way to do it. So from our point of view, local variables are defined. Then we'll use variables to define functions. And then we'll see how we can use functions to actually define local variables. We'll do that last. Okay, so we run out of time. We should quit here. Okay. Okay, wait. So start reading language 7. What I mean by that is read this text file here that defines the language. Read this, okay? And I'll give you some other readings as time goes on where other people's, there's a lot to say about this. It's really a deep issue. You know, functions are really, they're the heart, They're the heart of programming. So there's a lot to say about them, but start by reading this guy, and then I'll give you some other readings as we go on, and then we'll see how we actually implement function definition and function application. Okay, function definition and function application, how the interpreter actually does them. Okay, all right, so I'll quit there. And again, look at the next program assignment. And if you have questions about it, as usual, send me email or come to office hours, whatever, and ask about, start looking at the homework assignment. Okay, any questions left? Any questions at all? Anything? Okay. I'm gonna go ahead and stop sharing and end. If you have, after you look at the homework assignment, if you have questions about it, please get a hold of me. Okay. So see you on Wednesday. Bye.